So now we will see about Krushkal algorithm, which is basically used to find out minimum cost spanning tree of a given graph G. So it is completely based on the concept of choosing edges having less cost. So first of all, we will see what are its properties, and first step before going ahead with the algorithm, you should remove if there are any parallel edges given in the graph. So let's say if a graph has a parallel edges, let's say this is and one more edge is here having cost 10, then there are two edges from A to B. In that case, we will first of all remove that additional edge which is having more cost. So in the further steps or consideration, we will always go with less cost edge, and we will remove additional edges or parallel edges if it is anywhere in the graph, and then highest cost edge will be in parallel will be removed. And second important point, if it is containing any loop, self loop kind of things, then also this cost will also be removed. So let's say there is one loop kind of situation in this and having cost, let's say 2, then this thing will also we will remove, we will not consider take into the account. So once we are over with these two steps, then we will go with our methodology of Krushkal. So what basically Krushkal states? Basically it states that you simply arrange all the edges cost in ascending order of their fashion. And let's start with this. So we have a cost with cost 2 here. Between BD we have a cost of 2, and additional anywhere we have more cost, no, we have cost 2 only here, and then we have cost 3. So for 3 we have 2 cost, let's say AC we have 3 and CD also we have 3, and then we have next cost having 4, so that is BE. So BE will be having 4, and then DE also we have 4, and then we have 5 between A to B, cost is 5, and then C to B we have cost 6, and between F to C, F to A we have 7, and F to C we have 8. So this much number of edges are there: 1 2 3 4 5 6 7 8 9. So we have noted all the cost 4 plus 5. So all cost we have noted in order of increasing order. So first of all we have written smallest cost, and then in so way. Now what it states basically, in next step you will choose the edge starting with minimum cost. So first of all we will choose BD. So BD we will be choosing having cost 2. Another cost AC we will choose. AC is having 3 costs, no issues, A and C. We will keep on adding one by one till we are getting any, let's say, cycle. So that edge we will not include in our tree, because tree does not support any cycle. So we will be very careful whenever we are selecting any edge. If it is creating any cycle here, we will not include that edge. So this thing we will include, this thing will include. Now CD is carrying cost 3, so no cycle, so we will include this also. For BE, B to E we have a cost of 4, so that thing we will include. Then DE, we will not include DE, because if you are including DE it will create a cycle. For AB also we will not include, because AB again creates a cycle. And for CB also we will not include, because CB also creates a cycle. FA we can include, so FA we will include 7, and we cannot include FC also because it creates a cycle. So Now everything we have included, and this is basically a spanning tree minimum cost MST we got as an answer. So what is the total cost? 7 plus 3 plus 3 plus 2 plus 4, 10, 13, 15 to 19. How many number of vertex in the spanning tree? Same as original graph. A, B, C, D, E, F. And how many number of edges? Number of vertex minus 1. So how many number of vertex are there? 1, 2, 3, 4, 5, 6. So how many number of edges would be there? 1, 2, 3, 4, 5. So there are 6 vertex. So number of edges in MST is always number of vertex minus 1 is total number of edges, that is 6 minus 1. So we got 5 edges with the total cost 19. So this is the way basically we do. In summary, simply we arrange the edge cost in form of ascending order. Choose one by one edges, include in your tree once new edge is coming if it is not creating any cycle, because tree does not support any cycle. We will not include that edge in my MST. So that is all about minimum cost spanning tree, and method we have used here is Krushkal algorithm. The Krushkal algorithm, two things are very important. You first of all remove any parallel edge which is carrying higher cost, and if there is any self loop you remove that, and later on you simply arrange the edges in the form of ascending order cost of their edge cost and choose one by one. That's all. Thank you.